Okay, we're going to talk about period change with the sine function. Now, sine and cosine, the period change is very similar. It's the exact same. So given that we have some amplitude, so represented by A, being multiplied to either sine or cosine, but we have a number attached to x that we're going to call b, then to find the period change, so the distance that we start to repeat the pattern, we can use this formula, 2 pi, one time around the circle, divided by whatever that number is attached to our x or our theta. So let's take a look at number 1. I wanted to write, technically this is a total of 4 periods of the parent function for sine. So we started here, one time around, get back to our starting point, that's 1 period. That'd be 2 periods, here's the third, and here's the fourth. So I wanted to do that to show you the difference of how the parent function would look with 2 examples that have different periods, some less than the original and some greater than the original. So let's deal with purple first. So sine of 2 times x. So if I want to find my period, we're just going to represent that by the letter p. 2 pi over b, or the number attached to our variable. And so that'd be 2 pi over 2. Now these simplify to give us 1, so after we cross them out, we get that the period is 1 pi. So meaning the time it takes, or the distance it takes, for us to go from where we started to where we come back, instead of being 2 pi, it's going to be a distance of 1 pi. So half the distance of the normal parent function. So let's take a look to see what that might look like. So sine starts at the origin. It starts at 0, 0. But notice how we're going to do the entire thing and end at 1 pi, because the distance from start to finish is going to be at 1 pi. Now, we want 4 tick marks to go from where we start to where we finish. I only have 2, so 1, 2. I'm counting that as a tick mark. So we need to write in, so we have a total of 4. So I'm going to go halfway between the first and the second and the third. And so notice from where I start, 1, 2, 3, 4. We want 4 tick marks. Why? Because around the unit circle, we would have 4 tick marks from 0 to 90 to 180 to 270, back around to 360. And so because we would have 4, we want 4 tick marks here as well. Now, what is, if my whole period is 1, what's halfway from 1? Well, it's going to be pi over 2. Now, if half of my way around this period is pi over 2, what is half of that? Anytime you take half of a fraction, you're really just multiplying by 2. So this becomes pi over 4. And then if I take pi over 4 and multiply by 3, right, if that's my first tick mark, to get to my third, I can take my first tick mark and multiply by 3. So multiplying that by 3 makes this 3 pi over 4. Now, that is going to take a lot of practice for us to recognize how to find these other tick marks and their fractions. But I'm not going to do all of these periods, but I do want to at least give you an idea of what it may look like. So starting at 0, my first tick mark, here's my midline. My first tick mark for sine function is going to take me to my maximum. My next tick mark is going to be back at midline, down to minimum, back up to midline, and then following that pattern, maximum, midline, minimum, midline. And that'll be good for right now. It would continue on, obviously. It's a little hard to see with all the dots and the black and purple are starting to mix. But if I follow this pattern, so here we are, if I follow this pattern backward, midline, back down to minimum, back up to midline, maximum, midline, minimum, midline, maximum, midline. So if I draw this new function in purple, notice how it's going to go through the space twice as fast. And it would keep going. So where a traditional period in black of my parent function would be this length, a period now of 1 pi is only this length, so half the distance. So it's going to complete a period twice as fast. So this is going to complete a period twice as fast as my parent function. So if that wasn't confusing, Now we're going to add a little bit more to it with orange, and I hope we can see this okay. But what happens if this number b, the number attached to my variable, my unknown, my angle measure, is a fraction? So given the function, period is 2 pi over whatever that is, which in this case is 1/2. Now, we cannot divide by a fraction, but we can multiply by its reciprocal. So if I flip this fraction, which is the reciprocal, what is 2 pi times 2, or 2 over 1, right? The reciprocal of 1/2 is 2 over 1, which is just 2. So 2 pi times 2 tells me that, hey, this period is going to be 4 pi. Okay, that might seem like that's going to be a little bit easier. So we'll see, meaning that my 4 tick marks, my 4th tick mark is going to be 4 pi. So if I look, I'm still going to start here at 0 because I'm dealing with the sine function. But my last tick mark is going to be over here at 4 pi. Now, what is the halfway point here? Well, the halfway point is here at 2 pi. What is halfway between 0 and 2 pi for my first tick mark? Well, that's going to be 1 pi. And then if I take 1 pi times 3, that'll give me my 3rd tick mark, which is 3 pi. So 1 times 3 is 3. So we have 4 tick marks in this period. We have, starting from my origin, my midline, we have 1, 2, 3, 4. That is going to be 1 period. So this is going to be twice as long as my parent function, or it's going to take half the time as my original. Or I'm sorry, my parent function is going to be half the distance. So from here, start at my midline, my next tick mark, I go up to my maximum. My next tick mark, I'm back at my midline. My next tick mark, I'm at my minimum, which is still 1 and -1. And then finally, completing this whole thing. Now, working backward, going to -1 pi, minimum, -2 pi would be my midline, -3 pi would be my maximum, and -4 pi would continue out or finish that period. So let's go ahead and draw this. So from here, notice how it's a little bit wider. So we have a lot going on here. In the black, we have our parent function in the dotted line. Sometimes our new period change can be a lot quicker. It's going to be a lot faster. So in our example, in the purple, it's going to complete a period twice as fast as the original. I stumbled over the orange and how to explain it. In our orange function, it's going to complete a period half as fast as our original. So it's going to take a lot longer than for this to complete 1 period than it would for our original. So sometimes it can be quicker, like this purple example. Sometimes it can be slower or take longer, like the orange example. But comparing it to our original function, notice we're not dealing with amplitude changes. We are only dealing with how quickly our pattern starts to repeat. Our next video, we're going to talk about how this looks when we change amplitude and period changes.